Hey y'all, so today I'm going to finish up the problem that I started with yesterday on area and perimeter. And so when I left y'all yesterday for pre-algebra, I gave y'all a problem that had two shapes together. It was a composite area, so we had to break it up, and then in this case we're going to have to use the addition method to find the area. And so to do that, I showed you that we can cut it here. You can get a semicircle and a rectangle. Gave you the formulas for those two shapes, especially for the semicircle. You won't see that on your formula sheet. It will be a full circle, but a semicircle would just cut it in half. So that's why we divide by 2. You could also multiply it by a half instead. So either of those are fine. So let's work through that problem real quick. I'm going to erase this. Actually, no, I'm not going to erase it. I'm going to move the perimeter piece. So, to that in a second. Alright. I'm going to erase total because we don't need that right now. Alright, so to do the rectangle, we need the length and the width. So it's up to you at this point. You can either use 5 or 7 because right here is our rectangle. I'm going to highlight it just really quickly. There's our rectangle. Sometimes it could be, I know it kind of looks like a square, but the dimensions are a little bit off. Pay attention to dimensions. Don't just assume that it's a square. Sometimes you may have to subtract to find out what the actual length is, and it ends up being a rectangle. So just be careful with problems like this. Okay, so rectangle, length times width. Area equals, I'm going to use 5 for my length. You could have used 7. Width is going to be 7 for me for this case, but you'll still get the same answer, and that's 35 units squared for our area for the rectangle. And then for the semicircle, the radius is 2.5. That was not originally given, so if you did not watch the video from yesterday, you may think then that this was already given to us, and it wasn't. We had to look at this. So the diameter or straight across was 5, and since the diameter is 5, the radius is half the diameter, so that's going to be 2.5. So 2.5 is what we're going to use for our radius, so the area of the semicircle is going to be 3.14. That's the value we're going to use for pi. Radius is going to be 2.5. We're going to square that number, and then at the very end we're going to divide by 2. So 2.5 squared, I'm going to bring that up real quick on the calculator so we can just plug this straight in. Here we go. So 3.14 times 2.5 squared. I just want to make sure that you can see the calculator. Squared 19.625. And then we're going to divide the whole thing. Let's go ahead and put this in parentheses. So I would strongly recommend putting the first bit in parentheses if you're going to use Desmos right off the bat. So you could do this portion first to find the area of the circle, then you can press enter. And at this point, there's a little answer button right here, ANS, that stands for answer. So it uses the last number you got, which was 19.625. And I'll put it there right there for you, or you can type it in, and we're going to divide that by 2, and we get an answer of 9.8125. Now for this, I'm going to write that entire number down because there may be the case that you have to round at the end, and it's always best to do it at the end, so just keep that number in mind, the 9 point. So area of the circle, 9.125. So wrote that down, and we're going to then add these two together because it's an addition composite area because the two pieces are still together. So we're going to add them back together since we found the areas of the two separate shapes. So the total 35 plus 9.8125. add these together, because this 35 doesn't have it's just a 0.0 for a decimal, so the decimal points will be the same. I'm going to go ahead and round this to the nearest hundredth, so the second decimal place, so that's going to be 0.81. Now if this had been a different decimal, I would have added those, wrote that down, and then rounded it after that. But since we're only dealing with this decimal, I went ahead and rounded beforehand. So 35 plus 9 is going to be 44, and those are going to be units squared, so this would be our final answer. And of course you could still use Desmos. I was just doing that in my head real quick, so just to show you on Desmos. Again, I'm going to press enter and start with a new line, and I'm going to use answer again because that's the number that I'm using anyways, that 9.8125. I'm going to add 35, which I did here. We can move that around because of the commutative property of addition. So again, 44.8125, I rounded because it's a 2. If it's 4 or less, we keep the same, and if it's 5 or more, we round up. Alright, so we got 44.81 units squared. Okay, so then I asked you to do perimeter, and I said that we're going to deal with the circumference this time. So that's our perimeter of the circle. So let's find the circumference first. So I'm going to move down just a little bit, just so see this a little bit better. Green. Okay. Perimeter of this semicircle was pi d divided by 2. So the diameter was actually already given to us. So if this is 5, this is 5 as well. Oh, you can't see that. I'm sorry. This is 5 as well because it's a rectangle, so the sides are congruent. So we're going to have pi, the diameter was 5, and at the very end we're going to divide by 2. If you wanted to, you could also have used, I'm going to write or 2 pi times the radius, which is 2.5, and divided by 2 at the end as well. That's another option you could have done because both of these are the same. So 5 times 3.14. Hold on one second, y'all. I'm really sorry to mess them up. So I'm sorry, y'all. All right, I'm back. So where was I? I need my calculator. So let's clear this from the last problem. Clear. And 3.14 is what we use for pi. We're going to multiply it by 5. We get 15.7. And again, since we're dividing by 2 at the end, please press enter to get a new line. Do the answer button. Or if you want to type in 15.7, that's completely okay. But then you'll do divide by 2. And we get a circumference of 7.85. So that's an option for you to do it this way, and I'm going to show you real quick. I know it seems redundant for me to solve it again, but again, I just want to show y'all if you had just wanted to stick with using the radius, you can use that as well. So I'm going to press enter on Desmos to use the other line. 2 times 3.14 times 2.5, you get 15.7, and I'll even show you 15.7. I typed it in instead of using the answer button, divided by 2, and I get the same thing, 7.85. All right, so we could have used that as well. I'm going to clear all this because we're going to need that in a second, because now we're going to start adding up our sides. So with perimeter, we have the curved surface here, the circle. So this is good. So we have this distance. That's 7.85. Let's go ahead and just write that on there for us. So that's this entire distance here. So we have this. then we need to think about what is this length right here. Well, since it's a rectangle, if this is 7, this is 7. They're congruent. But we do not need to worry about this 5 and adding up because that's on the inside, that's not on the outside. For the perimeter, we're only caring about the outside. So since I already have 7.85 written, well, I'll write low. So like I told y'all, start with a corner. I'm going to start with this corner, and this time I'll start adding up to the counterclockwise. So let's go 5 plus 7 plus 7.85 plus 7. And when you do that, then we're just going to add them all together. I already have the calculator up, so let's go ahead and do that. Oh, and another just quick little tip, if you need to, just to make sure you covered everything, you can do like a little check mark next to the dimension or cross it off after you're done adding. So I can do that as well, like I just did. So add those up. So 26.85 is our final answer, and it's already to the nearest hundredth, so I don't have to worry about rounding. And that's just going to be units. We don't have to worry about square units because again, we didn't multiply units times units. We just added them all together. You can kind of think of the same way when you're multiplying like a variable, like x times x gives us x squared. So that'd be the same thing with units. A unit times a unit is a unit squared, which we haven't gone a whole lot over in pre-algebra, but you will see a lot of that next year, especially when you get into what's called the law of exponents. But that's ahead of it, so you don't have to worry about that right now. Anyway, so that was this problem. I'm gonna zip through a subtraction problem. Ignore that one. Let's work with this one. So with this one, I know we've been doing a lot of addition problems, so instead of adding, this time there's a missing piece. So you could think of this as like you were trying to make cookies. You have this big sheet of cookie dough, and you're starting to cut out circles or cookies out of it. So now you need to figure out how much of your cookie dough is left after you've taken out this piece. So this one we're going to end up having to do the subtraction method. So let's start with labeling our shape. So the two shapes that we see, if our big shape is going to be a rectangle, and the shape that's missing, or small shape, if you want to call it that, is a circle. So big minus small, we're going to do the rectangle minus the circle. So we're going to find the area of the rectangle. And the area of a rectangle, just assume that. Okay, so area of the rectangle, area equals length times width. So we're going to do our length, which is 11, times 5, and I didn't use the parentheses this time, so I'm going to go ahead and fix that with the parentheses. You could also use the little multiplication symbol, but don't use the x, because we won't be using the x anymore, because most people are going to get confused with it being a variable at this point. So 11 times 5 is 55, and we have our first area of the rectangle. You could also, instead of using a, I know we've been labeling stuff with just using like the letter of the shape, so we could just call that r instead for what we just found. And then for the circle, the area of the circle is pi r squared. So at this point then you are going to want to find out what the radius is of this circle. Now the problem with this is that they don't have this dimension labeled, but do we know anything about this circle? Well, let's look around. So 11's from this side to this side. That goes through there, but that's a little bit over. But then if we look at our width, and you look at the shape of the circle, the width touches the edge and the edge of the circle. So if we were to draw a line right here, we would have the diameter. So if we know the diameter, we can find our radius which is half our diameter. So if our diameter is 5, then our radius is going to be half that, so 2.5. So we're going to end up using that again. I didn't even realize that, so 3.14. Oop. Cool. Glad that just happened. Sorry, y'all. Hold on one second. Well, since we're already over there, so we use the exact same thing, so, oh, well, no, we'll have to double it. Never mind. So 3.14. Radius squared, so 2.5 squared. And we'll go ahead and we're going to put that into the calculator and see what we get. So 3.4 times 2.5 squared. So we get 19.625, and I'm going to write that. So now at this point we have both our areas. So instead of adding though this time, because we're worried about the shaded region, so the one that is not missing. And again, I talked about this briefly yesterday, but you can think of this as like in terms of art, like negative space, so space that's not there, it's not filled in. So we're looking for we're going to take out this missing spot, and that missing spot's this 19. So let's do 55 minus 19.625, and we're going to find our total area. So the total, now in this case you can do, instead of just typing answer right off the bat, we can do the 55, do 55 minus answer, and again we'll still use the same answer we used up here. You don't have to be pressing that first. So then we get 35.375 for our total. So I'm going to round that to the nearest hundredth. So I'm going to write it first. 35.375 units squared, but I'm going to round up to the nearest hundredth. So I'm going to look back here. This is a 5. So because it's a 5, I'm going to end up rounding up. So that's 35.38 units squared. So that will be our solution. It's right there. All right. Oh, and it would probably help if you could see that. So that's how we do that one. We're gonna move on to one more. All right, so also going to check one thing real quick while this is, so we have our dimensions up, so I want you to think about what shapes you have here and write those down, and then what area formulas you need to know, and then you're going to check with me in just a second. Okay, so what'd you get? You should have gotten a trapezoid. It's right here. That's our trapezoid, and then a semicircle. So let's write green this time. And I know it's kind of difficult to see since it was like someone took a bite out of it, but if we had drawn a line straight here, you could see that it's still a trapezoid, and this is a nice isosceles trapezoid. So to find the area of a trapezoid, it's A equals 1/2 base 1 plus base 2 times the height. The height is always perpendicular to the base. You'll see this little right angle mark. So in this case, the height is 3. The base 1 or base 2, it doesn't matter at this point. One of these bases is going to be 15, which they gave us. They did not give us the top one, but again, we can figure that out because if they gave us the radius of this semicircle, if the radius is 4, what do you think then we could use that with to find this top dimension? Well, if the radius is 4, that means then if we were to extend this and get the diameter, you could also find the other base length, so that would be then 8. So area equals 1/2 8 plus 15, and again I found that 8 because the diameter is also the same length as that top base, and then the height is 3. So using order of operations, we're going to do what's inside first. So plus 15, which is going to give us 23. So we have half 23 times 3, and I'm going to use my calculator to find out what that is. So 1 divided by 2. Please make sure when you're using your Chromebook to press the right arrow to get to the side of the fraction bar. You can also click over there as well instead. Then we're going to multiply 23 times 3, and we get our answer is 34.5. So the area equals 34.5, and I'm really sorry, for some reason it keeps thinking these gestures are going to be circles, and they're not, so that's why I keep editing it back. So there's a parentheses. If you accidentally wrote a circle, go ahead and erase that. It's supposed to be parentheses. Alright, so 34.5 units squared, and I'm not going to worry about writing the units squared for right now because I need to then find out what is missing. Now let's say you didn't want to do the 8 plus 15 in your head or write that down. You could also put it in straight into the calculator. So you could write this as 1/2 parentheses 8 plus 15 in parentheses, and then use the parentheses again to put 3, and we still get the same answer. So that's another way you could have done that as well if you didn't want to do this extra step that I showed. Alright, so I'm going to leave that up here. So I'm going to just slide this to the right just a little bit so I can see, get the semicircle out, because it actually, okay. So now we're going to find out what that area of that missing piece. It's like someone had a trapezoid shaped sandwich and they took a big bite out of it, so now we're going to find out that missing piece that is gone, bite that they took out. So again, we're dealing with a circle, but not more specifically, we're dealing with a semicircle. So we're going to find the area of that semicircle first. So normally the area of a circle is pi r squared, but since it's a semicircle, it's a half circle, we're going to divide by 2. So let's find out what the radius is going to be used. They gave to us as 4. So area equals 3.14. Radius squared is 4 squared. And we're going to divide by 2. Alright, so let's put that in our calculator. So A equals 10. Now let's say you wanted to put this all in one go. How would you do that in Desmos? So the first thing I would recommend doing is having the fraction bar first, okay, because you're going to divide by 2 at the end. The next thing to do is that after you put the 2 in on the bottom, you can press up on the arrow, on the D-pad or the up arrow, and then you can also just click up here and put 3.14 times 4 squared, and you get 25.12. So that's one way you can put it all in one simple entry. So our area of that circle is 25.12. Now, at this point, what are we going to do? We are going to then subtract the 2 because this semicircle is missing. It's gone. So we're going to then subtract the 2. So we're going to do the total. 34.5 minus 25.12. Subtract these two. Again, I'm going to go ahead and just use my calculator real quick. So you can put into 34.5 minus 25.12, and you get 9.38. So 9.38 units squared, and that would be our final answer. Now, I don't know if you would have a problem like this for perimeter, but if you were, this would be a kind of a challenging one, and let's do that real quick, and we'll stop after that. So I don't think you, like I said, I don't think you would have something like this, but maybe it kind of depends. So what I'm going to do is I'm going to erase this, but I'm going to leave up trapezoid and semicircle. Oh well, I guess not. Maybe not. So with this one, to do the perimeter is going to be a little challenging, but we're going to go ahead and try that. So we were given 15. Remember the perimeter of a circle, we're going to have to do circumference. So we're going to have to find the circumference of this dimension right here, this circle I mean, and we're going to have to do half of it. And then we're going to actually have to find out what these lengths are. And the question on how to do that is, that one's going to take a little bit more work. So I'm going to do the semicircle first. So the semicircle, in order to find circumference, let's use 2 pi r, okay? That's normally what we would use for a circle, but since we're using it, since it's a semicircle, we need to find half of that. So at the very end, we're going to divide by 2. So it would be 2 times 3.14 times the radius, which is 4, and then finally just divided by 2. Okay. Now some of you might catch on already at this point, but since we're already multiplying by 2 and we divide by 2, they would cancel out, but if not, it's okay. So let's just put it all in one go. I'm going to go ahead and press the division symbol to give me my fraction. I'm going to do 2 times 3.14 times 4 for the radius and divided by 2, and we get 12.56 for that circumference. So that's one dimension we got. We have the 15. Now we need to find these other two, and I'm going to assume that this is an isosceles trapezoid so that both those dimensions are congruent. So I'm only going to have to find it once, and I'll know what they are for both sides. So to do this, I'm going to imagine that there's a line right here, okay, and it's inside the shaded region. Okay, and it makes a right angle with the base. So if this is 8, this is 15, I have to find out what this missing dimension is here to get this length, and I already know what this length is because that's 3. And then we're going to use the Pythagorean theorem. So to find the side lengths, of the trapezoid, we're going to have to use the Pythagorean, I'm going to shorten that, theorem. So that was a squared plus b squared equals c squared. And we're looking for the hypotenuse. We know the 3, so we know one of the legs. Now we have to find the other one. So if this is 8, this is 15, the difference between those two is going to give me these sections put together. So 8 minus 15 is 7. So that means then that this length plus this length is going to be 7. So if I needed to split that evenly, I would just divide by 2. So how did I get this length? It's going to be 15 minus the 8, which is the top base, it's B1. And then we're going to divide by 2 because there's 2 of them on each side and they're equal. So 15 minus 8 is 7 divided by 2, so that means then it's going to be 3.5 is that other leg. Okay, so that's 1. So let's try to find then our length. So we're going to do 3 squared, and we get that from here. This is this. So 3 squared plus 3.5 squared equals c squared. So let's use our handy dandy calculator and clear. 3 squared is 9, and then 3.5 squared is going to be 12.25. So I'm going to write those down real quick. So now I'm going to add those together. So I'm going to enter. Cool. Enter. So I'm going to use the 12.25, add the 9 to it, and I get 21.25. And then the last thing I need to do, I don't care about what c squared is, I care about what c is, so I'm going to square root both sides. So that's 4.61 is what I'm going to make that, 4.61. So that's what one of these sides are. So this is 4.61, and then this is 4.61. So now what are you going to do? Add up all the sides. So starting at one corner, I'm going to go clockwise this time, so this way. So we're going to have 4.61, that's this dimension, so we got that. Then we need this top distance, I'm sorry, the circumference distance, so that's 12.56. Now we need to come down the slope, so that's 4.61, so I'm going to add that. And then the last thing I need to add is this bottom distance, which is 15. I'm going to add that. So you're going to put that all in your calculator. And you get 36.78. And that would be our final answer. Again, I don't know if you'll have something as lengthy as this, but this was a pretty challenging but good thinking problem to go through, especially when you have to think about if it's an isosceles trapezoid. Now, if this was not an isosceles trapezoid, so that means that both of these sides were not congruent, then 9 times out of 10 they would have given you those dimensions. But in this case, they didn't, and we had to find them, and I wanted y'all to work a little bit on that problem. So it was a good way to end with that. I miss y'all. I hope you're doing okay. I am going to stream again on Monday for pre-algebra starting at 2. And then again, algebra is going to come right after, which I'm going to start up in just a second. But have a good weekend. Rest up. And if you have any questions, just let me know. Email me. Leave a comment. Give me something in Google Classroom. Whatever works best for you, just let me know. Please work on any of your missing work too. So if you get any of that stuff done, please email me so I can update that as well. All right, have a good weekend, and now it's going to be time for algebra, so un momento. All right, y'all, so we're going to go back to systems. And we're going to go over the last problem I gave with y'all. This was I asked you to do at least a graphing and then either substitution or elimination. So I am going to go through the graphing portion first. I'll leave Desmos open. And then feel free to ask questions if you need to ask questions for this. This over here. All right. So for this, the graphing portion, you need to make sure that this is in slope-intercept form, which this is not. It's in standard form. So for each one of these, I'm going to convert these really quickly to slope-intercept. I'm going to go ahead and color code the way that I'm going to plot these. So this one will be in red. and then the next one's going to be in green. And I'm going to convert the negative 7x 13. Okay, so with this portion, to do this step, you need to remember literal equations, so you need to be able to isolate one of the variables that they ask you for, and in this case, we're going to isolate y. So to isolate y, I am going to add over 7x to get rid of 7x. So if I add, I'm just trying to get something so it looks like it's, you can see, add 7x, add 7x to both sides to isolate. This cancels. So when you do that, you get negative 2y equals, please put the 7x first, put the variables first. And this is actually going to bring a good point because this is going to come up in when we start polynomials. There's standard form for polynomials, and that's where you put in descending order of your variable. So in this case, we have a variable 7x, but this negative 13 is what's called a constant. We should remember that from last year and from when we went over multi-step, and since it doesn't have a variable, it lacks what it's called a degree, and again, we'll go over this either next week or the week after. And that will make more sense at least next week. So that's why the 7x comes first. It's also good notation too, since it's a linear equation. Now we're going to divide by negative 2 on both sides to isolate y. This cancels, and I am left with y equals negative 7/2 x plus 13/2. So this is going to be a tricky one to plot, but I think we're going to be okay. So I am going to erase this portion. I'm going to write this above, right? So just so we know what we're dealing with. Then I'm going to go ahead and I'm going to erase this bottom portion. Delete. And I'm going to start solving out then for this one. So the first thing I would want to do for x minus 2y equals 11, I would subtract the x over. Ahead of myself. So these cancel. I'm left with negative 2y equals negative x plus 11 divided by negative 2, divided by negative 2. Negative 2's cancel, and I would have y equals, so I'm going to write this as x over 2. It's a double negative, so they cancel out, minus 11 over 2. However, how you would really see this, and I'm going to go ahead and write that underneath, is y equals 1/2 x, because if you divide by 2, that's like multiplying by 1/2. If you were to cut something in half, you're dividing it by 2, right? So gave it the coefficient, so, and then over 2. So this is what I'm going to write underneath here for us to use, and now we can start to plot. If I am moving too quickly, please pause the video just so you can kind of see what's going on. If you have questions on this, please email me, ask me in any form that you'd like, email. If you're here live with me, then you can ask the questions now. You could send something in Google Classroom, whatever you'd like. So now I'm going to plot. So I'm going to plot this first. This is our y-intercept. So this is negative 11/2. So if I was to make that a decimal, 11 divided by 2 is going to be negative 5.5. So I'm going to try to plot that as best I can. So 1, 2, 3, 4, 5.5. So do that one more time. 1, 2, 3, 4, 5.5. And I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, so on and so forth. So it would look something along these lines. No pun intended. So we have a positive slope. I'm not going to connect this just to keep an interest of time, but this is what it would look like. It'd look like this line. And then I'm going to plot my red line. So negative 7 halves x plus 13 halves. So 13 divided by 2 is going to be roughly 6.5. So again, I'm going to try to plot that 1, 2, 3, 4, 5, 6 and a half is here. I'm going to go down 7 and then over 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. So we ended up not being able to plot right off the bat where our intersection is, but I can probably guess where it's going to be just looking at the graph. But this is where the line would look like. This is what that would look like. This is a good case in point of why sometimes graphing it by hand is not always the easiest. I know graphing is pretty common, but there's some times where even if you were to put this into Desmos, the intersection may not be an integer. It might not be a set of integers. It may be a decimal point, and those decimal points aren't super accurate unless you have it in fraction form. And how can we do fraction form? By solving it algebraically. So that's when substitution and elimination really comes into play, because solving it algebraically, we can be as accurate as possible, which is really important, especially if you decide to go into the STEM field. So what I mean by that is science, technology, engineering, or mathematics. Those are really important to be as precise as possible, especially my engineering degree, where we were required to be super precise, and we also had standard deviation we had to calculate each time, but that's another story. So anyway, let's put this into Desmos real quick. What's nice about Desmos, I do not need to put them in slope-intercept form. I'm going to put them in just the standard form they gave us. So I can plot the y, I could even plot the y-intercepts. I could have done it that way as well, since I did have the, I was in standard form. So don't forget about that as well. First line. Second line. And it looks like our intersection is at 3, -4. And let me just check on our graph. 3, 1, 2, 3, 4. Yeah, that's where I thought we were going to cross as well. So our intersection is at 3, -4. So I'm going to write that over here. So this would be our intersection, because there's only one intersection that we goes through. That means then there's at least one solution. There's not infinite, there's not no, it's one solution because they are intersecting lines. So now let's try and solve it with, let's do substitution, because I think that would be easiest in this case. So I'm gonna erase this, and I'm gonna erase this, and I'm not gonna worry about this anymore. And let's erase that. Okay, so if I wanted to solve it by substitution, I need to solve for a variable. Now in this case, there is more than one way to go through this. You can pick one of these equations and then pick one of the variables in those equations to solve for. If I was looking at this, there's 4 different ways to solve this. So, or to start this, I mean. If it were me, I would solve for the one that doesn't have a coefficient. Solve for x, because that doesn't have a coefficient. We don't have to divide by anything. It's a positive coefficient because it's a positive one. If we had a negative, then we'd still have to divide. But in this case, equation 2, x would be the easiest one to solve for. If you wanted to solve for, let's say, the x that was in this equation, you can. Or if you wanted to solve for this y, you can. You can solve for this y. It does not matter. Just go though what is easiest for you, because it will make things move much quicker. So I'm going to solve for this x. If you want to solve it a different way and still check your answer, please do that. If you want to wait until I'm done, that's fine as well. But I'm going to solve for this x. So I have x minus 2y, so 11. To get this x by itself, I'm going to add 2y. to both sides. Cancels. I'm left with x equals 2y plus 11. Now, this is what I got. So anytime that I see x in the other equation in the top one, I'm going to put this in there. So I'm going to take this. I'm going to rewrite my second equation. So negative 7x minus 2y equals negative 13. And I am going to plug in, anytime I see an x, right next to the 7, I'm going to plug that in there. That's where that's going. So negative 7 times 2y plus 11 minus 2y equals negative 13. Now at this point, just distribute. So negative 7 times 2. Negative 14y, negative 7 times 11, that's going to be negative 7a7. And then minus 2y equals negative 13. So at this point now, just simplify. So negative 14y minus 2y is going to be negative 16y. And then we're going to have minus 77. And that's equal to negative 13. At this point, solve it like a two-step equation. And I'm really sorry that the calculator is still up. And you can't see any of this right now. So you should be able to see it now. And the paper is getting a little crazy, so I'm going to scroll down just a little bit. So at this point, then I'm going to add the 77 over. (16y) equals then if you need to use your calculator, do that real quick. So that's negative 13 plus 77, so that's going to be 64. And then we're going to divide that by negative 16 on both sides. So y equals negative 4. And was that our y value from graphing it? Yes. So we're doing okay so far. So now that we have our y value, we need to plug it back in to one of these equations. Please use the original. Do not use what you solve for, because if you made a mistake somewhere where you were solving for a variable, you could have messed up, and then the mistake carries through. Algebra is a lot of just simple mistakes that carry through the problem, and that's where we can go wrong. So what I'm going to do is I'm going to plug negative 4 in. I'm going to plug it into, I think, again, the second one. I think it's a little bit easier to just do that. I don't have to divide by anything. So let's go ahead and do that. I'm going to rewrite that over there in red. Actually, no. So I'm going to write it right here. So I'm now going to do x minus 2y equals 11. So anytime I see a y, I'm going to plug in negative 4. So I get x minus 2 times negative 4 is 1. Negative 2 times negative 4 is positive 8 equals 1. I did something wrong. Did I do something wrong? Oh, yeah. It's not 1, it's 11. Mr. Parker is not thinking right now, so minus 8. Well, that. I was just talking about simple mistakes carrying around, and I made one myself. So please make sure you recorded correctly. That's a good situation that just happened, so 8 minus 8 is 0, so we're left with x equals 11 minus 8, which is 3. So we get x equals 3, y equals negative 4, so our solution set is 3, negative 4. And does that match up? It does. It does match up, so we did well. We did the right thing with substitution. Alright, so I'm now going to go through it now with elimination. So with elimination, you need to make sure the coefficients are matched up, and in this case, we already do have coefficients that are matched up, -2 and -2, but they are the same sign, so we're going to then have to subtract if they were opposite signs. So if this is a -2 and a +2, then we could just add. So I'm now going to solve with elimination. So I'm going to erase this. Make sure you have that copied down. If you don't have it copied down, go ahead and pause and then write it down. Alright, so to eliminate, we're going to then just write those problems again. So I'm going to subtract because the signs were the same. So negative 7x minus x is going to be negative 8x. Negative 2y minus negative 2, so that makes it a positive 2, so that cancels out. Negative 13 minus 11 is going to be negative 24. And then we're going to divide by negative 8. So x equals 3, we're off to a good start, matches up. So now at this point, we're just going to use, just like we did with substitution, and plug that 3 into one of these problems. I will plug it into the first problem this time, since I plugged it into the second one the last time. So negative 7 times 3 minus 2y equals negative 13. Negative 7 times 3 is going to be negative 21 minus 2y equals negative 13. Add 21 to both sides. Cancel. Negative 2y equals, so negative 13 plus 21 is going to be, so that'd be 7 plus 1 more, 8. Positive 8. Divided by negative 2, divided by negative 2, and you get y equals negative 4. And does that match up? 3, negative 4? Yes, it does. So again, we got the same answer. And I forgot the parentheses. So we're good to go. All right, 2 more. And I'm gonna go ahead and erase. If I'm moving a little quick today, I'm sorry. So just pause, copy down anything. If you have questions, please feel free to reach out to me. I'm gonna go over this next problem. Alright, so the next problem that we're going to work through is five x plus y plus 13. So just to make things a little bit quicker for y'all, I'm going to just put it into Desmos. I'm not gonna go ahead. I'm not gonna bother with hand graphing this, but if you wanted to hand graph this, you could have graphed with using I'm sorry, not slope intercept, the x and y intercepts. You can turn it into slope intercept, whichever is easiest for you. So to plug this into Desmos, again, you don't have to turn it into slope intercept. It will plot in standard form. Now, just as a reminder though, if you were to use your graphing calculator, your TI-83, it would not, you would need to turn that into slope intercept form. So there's our first line. Next line. Let's look where we intercept. So -3, -2. Now with this one, I'm going to go ahead and do substitution first and then elimination. Again, we can start from either one of these. It's kind of pick your own adventure, choose your own story type of situation of what you would like to do. So again, I would look for the one that doesn't have a coefficient, so which variable doesn't have a coefficient in which equation. So in this case, the second one, y doesn't have a coefficient, so I'm going to solve for y. If you wanted to, you could have solved for the y up here for the green. And what I am going to ask is if you would like me to solve this again with using a different one, I will gladly do that. But I'm not trying to waste y'all's bandwidth, your internet, so just let me know either by email or Google Classroom, and I will go out and set up another video to go through that, because I'm not trying to waste y'all's time on solving it the two different ways when you'd rather just do it the one that I show. All right, so let's solve this red problem for that y. That's a plus, so I'm going to add 5x to both sides. Cancels. I'm left with y equals 5x plus 13. So anytime that you see y in the other equation, you're going to plug in this. So rewriting. So I came up to my first y, so I'm going to plug in 5x plus 13 equals 3. So now we need to solve as if it was a multi-step equation. So we're going to do 3 times 5, or we're going to distribute the 3 into the grouping symbol. So -3x plus 3 times 5, which is 15x, and then 3 times 13, which is going to be 39. And that doesn't equal 0. Again, I'm sorry, I'm not paying attention to when they're doing the gestures thing, and it's... In fact, I'm going to go ahead and close that off real quick. Should stop. So I'm going to combine my like terms first before I start moving stuff over. So negative 3x plus 15x. If you want to move the 39 over first, that is up to you. That's more than okay. You still should get the same answer. So if you want to solve it that way, go ahead and do it. Just check at the end. Negative 3x plus 15x is going to be 12x. And then I'm going to subtract 39 from both sides. So I get 12x equals negative 36. I'm going to divide by 12 on both sides. So x equals negative 3. Does that match up so far? Yes, it does. So now I'm going to take this x and I'm going to plug it into one of these equations to solve for the y. Again, I'm going to use the second one because y doesn't have a coefficient in the second one, so this will be a little bit easier and quicker. And again, you're gonna put it into what you originally had. Do not put it into this one because you may have made a mistake. Put it into what you were originally, the original equation that you were given. So I'm going to write out the equation once just so you can see what I'm using. And then plug in with what I know. Negative 5 times negative 3 is going to be a positive 15. Y equals negative 2. Does that match? Yes, it does match, so it's the same thing. So our final answer is negative 3, negative 2, and that does match up to what we originally had, so we did well. So we're good. We're good. So, bueno, if you would like me to go through that again with using different equations, though, from these up here, just let me know. And I'm going to go ahead and erase that. Feel free to pause the video and record in case, because I'm going to go ahead and delete. All right, so if we were to eliminate, we want to look for ones where the coefficients are the same, and then in this case, we don't have coefficients that are the same. We have negative 3 and negative 5 for our x's, and then we have 3 and 1. So this one we're ending up having to multiply one of them by. Again, personally, the one that would be easiest is to multiply the second equation by 3 to match up. So then at that case, then it's just easier. If you have something with 1, it's much easier to match up to what's above it or below it, which is the other equation, because then you're just having to multiply by that one number. If we were to try to match up our x coefficients, we'd have to multiply not a common factor. We'd have to multiply by factors to give a common multiple, which in this case we would want a multiple of, it'd be 15 would be their common number, so we'd have to multiply this whole thing by 5 and this whole thing by 3. So again, it'd just be easier just to multiply this one by 3 so the y coefficients match up. So let's do that. So what I'm going to do is I'm going to write this up first over here. And then I'm going to go ahead and I'm going to write the second one in red underneath, but then I'm going to multiply. Actually, I'll just. So I'm going to multiply this by 3 because I want this to be common. And if you wanted to, you could even multiply not just by 3, but by negative 3, so then we can add instead of subtract. Both processes are the exact same, so you just look at the same answer, so it's just doing an extra step now rather than later, so it's up to you. I'm going to go ahead and just multiply by 3 though, so 3 times negative 5 is negative 15. 3 times y is going to be positive 3. 3 times 13 is going to be 39. So now I'm going to take this and write it right underneath. Right, and at this point, since the coefficients match up but the signs don't, we're going to have to end up subtracting, so I'm going to minus. So 3 minus 39 is going to be negative 36. 3 minus 3 is 0, so they cancel. Negative 3x minus negative 15, so you're adding 15, is going to be a positive 12x. So we're going to divide by 12 on both sides. So 12 divided by 12 is just 1, so you get x equals negative 3, so we're already off to a good start because they match up. And now we're going to plug it back into whichever one we choose. I will plug it into the first one this time since I plugged it into the second one the last time. So negative 3 times negative 3 plus 3y equals 3. Negative 3 times negative 3 is going to be positive 9. Subtract the 9 over. So I am left with 3y equals negative 6. Divide by 3, so y equals negative 2. And does it match up? Yep. So our final answer is negative 3, negative 2. It matches up to what we did graphically, so we're good. We're all good. All right. Alright, slight technical difficulty today again. I'm sorry. So we're back. I'm going to work through this next problem. And hopefully it won't go down again, so I apologize. Alright, so here we go. Eight x plus y equals negative 16, and it would help if y'all could see that. And then the other problem is going to be negative 3x plus y equals negative 5. This one's going to work out pretty nice for substitution and elimination really well. I'm going to graph it real quick first, and then we will start doing that. All right, so 8x plus y equals negative 16. We're going to put in our next one, so negative 3x plus y equals negative 5. So our intercept is going to be negative 1, negative 8. I'll write that down. And then we're going to check the other ways that we're solving it just to make sure that comes out to be true. All right, so let's substitute first. In this case, it really doesn't matter which one we solve for. Personally, this is just me just looking at this. I notice here, if I was to solve for y, I don't have to divide by anything, so I can bring this over. If I had to solve for y, I could move that over. So it really doesn't matter which one we solve it for. I'll probably just use the second one since they're smaller numbers. That's really up to you. So if you want to solve it with the first one and see if you get the same answer, go for it. Alright, so I'm going to solve negative 3x plus y equals negative 5. I'm then going to add the 3x over. And we get y equals 3x minus 5. So then anytime I see a y in the other equation, I'm going to plug that in. So starting with 8x, I'm then going to add my y value that I just found, which was 3x minus 5, and that's equal to negative 16 So I'm going to combine my like terms. 8x plus 3x is going to be 11x minus 5 equals negative 16. Add the 5 to both sides. Cancel. So you get 11x equals negative 11. And we'll divide by 11 on both sides. So x equals negative 1. Does that match up? Yep. And I'm sorry that that negative 1 looks so awful, so I'm going to fix that real quick for y'all. So now that I got my x value, I'm going to plug it into one of those equations. Again, it kind of just depends on which one you would rather use for this. I'll probably just use the first one. So I'm going to plug this in for wherever I see an x. So I'm going to write negative 3x, and actually I'm going to go ahead and just write out that equation one more time just to make sure I have it all written down appropriately. And then anytime that I see an x, I'll put in the negative 1. So negative 3 times negative 1 is going to be positive 3. So then I'm going to subtract 3 on both sides. And I get y equals negative 8. So our final solution is negative 1, negative 8. And does that match up? It sure does. So we are good to go. Now, if you had wanted to use the second equation instead to put in negative 1, that's fine. If you had wanted to use the first equation to solve for y, that's fine as well. You could have solved for x. There is 4 different ways to solve this problem, so there is 4 different ways that I could have solved this. So again, this is kind of a choose your own adventure when it comes to substitution. With elimination, you kind of just eliminate one of the 2 variables, so there's only really two ways to start it. And then from there, there's 2 ways that you can substitute it, so there's only really 2 ways you can solve that. I am going to go ahead and do elimination next, and then we'll call it a day from then. So let's go ahead and do that. So again, with elimination, since we already have our y's are currently the same coefficient, we can just go ahead and subtract because they're both additions, so we needed one of them to be the opposite sign, and in this case it wasn't. So we're going to subtract, so I'm going to go ahead and write this again, middle, right around here. So what you can do is at this point you're going to subtract. Now remember, when you're subtracting, you're basically just multiplying by negative 1 to each term and then adding them, so that's the same way. But 8x minus negative 3x, so that you're actually adding the 3x. So 8 plus 3x is going to be 11x. Y minus y is going to be 0. And then negative 16 minus negative 5, so you're adding 5, so that's going to be negative 11. Divide by 11, you get x equals negative 1. Are we off to a good start? Yes, we are. So then again, you can just plug that in. I already plugged it into the first one. I'm sorry, the second one, so I'll plug it into the first one this time. And we will have, oh, actually, let's go ahead and do this too, so it doesn't, let's cross that off. So 8x plus y equals negative 16, and then anytime I see an x, I'm going to put a negative 1 in. Add the y. So 8 times negative 1 is going to be negative 8. And then we're going to add 8 to both sides. So y equals negative 8. And does that match up? We had an x coordinate of negative 1 and a y coordinate of negative 8. Does it match up to our graphed solution. It does. So we are good to go. We're good to go. So like I said, there's more than one way you could have solved this if you had wanted to solve for the x coordinate first instead with elimination. You could have done it that way. That would just taken a little bit more work. I think with algebra, you want to try to make your job as easy as possible so there's less chance of mistakes. So that's why I would just go with solving for the y first in this case. But try it out. Try it out. You have the weekend to try that. Again, none of this is graded or anything. It's just kind of to help you review the stuff we already have done. As soon as I get more information on the new material, I will keep you posted in Google Classroom. So make sure you are keeping up with that. I think I'm just going to end up having though to download all of these videos and then upload them as soon as I'm done editing them to at least the Google Classroom because not everybody can see them online. But make sure you let your friends know that I am still streaming and stuff. I will be streaming on Monday, probably around the same time. I might throw in some new stuff then. Again, as soon as I know, I will let you know. And I'm going to make sure that y'all are ready for Algebra 2 in high school or Geometry, whichever one you want to take first. It kind of depends on what the classes that are offered. I do miss y'all. I hope you're doing well. Again, feel free to contact me. Any concerns, even if it's not about this class. If you want me to review some physics stuff, I can review some physics stuff, some biology. I could even do, I don't even know, y'all. I'm trying to, like, the playlist Palooza, I don't get to do that at the end of the year, so we could even do like a Friday where we watch a music video or two before we start working. I am here for y'all. I will do whatever it takes, and just even if it's some form of wacky, cringy entertainment to help y'all out right now. But stay safe. I love y'all, and I will talk to you on Monday.